Hi, everyone, and welcome to today's webinar on building effective data design patterns on using Click Data. We're just going to give a few more minutes for everyone to get connected before we start. Okay, so thanks everyone for joining in today's webinar. First things first, we just want to make sure everyone can see us okay, hear us okay. You also have a chat box on the right-hand side of the panel. If you have any questions throughout the presentation, feel free to drop us the questions and we'll answer them. The webinar is also recorded and it would be available on our website and on the YouTube channel. You can access it at any point of time from there. So just a quick introduction on what we're talking about today. Today's webinar is hosted by myself. I'm Shri. I'm the VP of Professional Services with Click Data out of the Toronto office. Along with me, I have Audrey, who is the lead data analyst at Click Data. She works out of the French office. And throughout our experience while doing some services projects with clients, we have seen some data design patterns which can actually simplify your reporting, not just on Click Data, but in general on any tool that you end up using. So we'll be talking a little bit about how you can do effective data designing to kind of make this reporting easier for you. On today's agenda, we'll be covering four main topics. We'll be talking about how and where you can use parameters. So Audrey will be talking about that. We'll also be covering a little bit about normalization, how you can create tables, crosswalk tables, and where you can use them. Then I'll be taking into some cross-functional analysis while working with multiple teams, what kind of data mapping can be used. And at the end, we'll be covering some different examples of cohort versus non-cohort scenarios, how to represent them, what kind of data structure you should have while working with those scenarios, followed by a question answer session at the end of it. With that, I'm going to let Audrey go ahead and start with the first topic on parameterization.
So thank you, Shri. So yes, the first part is parametrization. So in this part, what we will see is how can we set up parameters table and how it will facilitate the data analysis. So in this part, we will see first the definition, what is it exactly, and what is behind. We will also see some different use cases, so simple one, and we will go further with a more complex one. And then we will see how to use this type of tables, how concretely we do it, and then the benefits. So first, what is behind the parametrization? So the first thing that I would like to see with you is really the definition. It is a parameter is used to describe the entire population being studied. And so to really understand it, we can see what is a variable. So in contrary, a variable is a quantity which vary from individual to individual. So this is two really distinct things. So we are really used to use variables in our data, and sometimes we can have parameters. So in terms of concrete example, what do we have? What is the example? So in parameters, for example, we have worked hour per week. It will be the same value for all the different employees. It will be the same case for the number of days off per year. Or at least this kind of value can change depending on the country, for example, because it's rules at country levels. Or it can be also, for a third example, the hourly rate, which could depend, for example, of the function of the employee. So here it's always issue from different rules. And in the contrary, a variable, it can be the age, for example. So here we can really see that it will vary from individual to individual. It can be also the size or the seniorities. So here it's not issued from rules. It's really personal or individual data. Here it was example of data, but now that it's clearer on the definition, let's see a concrete example of how can we use parameters, in which case. In terms of examples, so let's assume that we are in a company with multiple sales representatives, and so that we would like to calculate their bonuses. So how could we use the parameters? Let's assume that this bonuses is calculated so based on their sales per month, and they get the bonuses only if the sales per month are above a certain threshold. So the threshold will be the value of these parameters. And we have multiple ways, in fact, to use that parameters. We can directly use it into the formula. So if we have this formula in multiple places in the dashboard, we will have to change the value in these different formulas. Or we can store that value in a parameter table, and we will see that later. So in terms of update, if the value needs to be changed, we will change it only on the parameter table and not on all the different formulas. And in terms of structure, the parameters table, we need to have so the name of the parameters, the value, so these two data are mandatory, and then we can also add the description and the format. So here it's a very simple case of the parameters, and what I want to show you now is a concrete example. So here in this example, it's directly in the dashboard. So what I will do here, it's the slide that we will have after the presentation, but I wanted to show you directly in the dashboard itself. So here it's the case where the parameters is directly into the dashboard. So just to describe this dashboard here, we are analyzing the results of the e-commerce platforms and the ads performance. So basically on the left, we have these results. Okay. So it would depend of the filters here and the date and so on. And on the right, we have these two slicers. So this one on the customer lifespan, and the second one on the leads conversion rate. And the thing is that it's parameters, because when I change this value, you can see that in multiple area in the dashboards will be recalculated regarding the new value. So if I change it again, you can see that the customer lifetime value evolves, and also here in this graph. And it will be the same principle with this one, which have also an impact on this graph and on these two values. So here it's the first example. So directly into the dashboard. The data here is not stored on the parameters table, but it's parameters. So if we go back to the presentation, so here, use case 1. Then a second use case that I wanted to show you. So you can see that it's still on the same kind of the dashboard. So for the example, what I did is that I put this slicer with the different currency, and it's also a parameter. So it means that you can have this graph with in dollars, or you can change and have the value in euros. Some other examples, you could, for example, change the unit in another kind of data for sure. Or another case, you can change, for example, the scale of measures. You can switch from thousands to millions. So here, on these two use case, it was simple case to address. It's directly into the dashboard. So it's accessible by all the end users. They can change it by themselves. And so the value can often change, and it's easy to do. And so it gives some autonomy to the end users. If we want to go further, and especially in this case, where we are changing the currency, we could have behind a parameters table with the value of the change rate, because we know that it's something that evolves over the time. And we can, to have really accurate results, we can, for example, store the value of the change rate like every day or at least every month to have accurate data in the graph. So it could be also something that can be done. And it's still easy on the graph for the end users to switch from dollars to euros. So here two simple cases. Now let's see how to concretely do it with the parameters table within the data model. So for this use case number 3, we will create a parameters table. So really the value will be specified into a table. So I took again the examples of the sales company with sales representative, where we want to calculate the sales bonus for each salespeople. So in terms of rules, it's still based on the total sales of a month for each of them. And we have 2 rules. The first one is that they get a bonus, for example, on their total sales. And the bonus is 5% of this total sales. And in addition to this, rules number 2, when the total sales are more than, let's say, 20,000 a month, the bonuses will be 350. So we have 2 parameters, and even 3, sorry. 1 for the rule number 1, and 2 for the rule number 2, which is the threshold and then the value of the bonuses. So in terms of structure, the parameters table will be like you can see in this slide. And here, what I've done to show you is that it's also defined at country level. So it means that the value of these 3 parameters can vary depending on the country. So you have certain value for US, and it can be different for France or UK and so on. So in terms of update, the value can be updated directly into your data model. It means that depending on where it is, it can be done by your data analyst who created this data model and who are using it in the dashboard. Or if it's done directly on a database, for example, it can be done most of the time by your IT department. So in this case, when it's not directly into the dashboard or maybe in an Excel file, it's done by the people in charge and not by the end users. And if we want again to go further, so here in this example, we have this value now for all of this country, but as it can be changing over the time, we can say that we want to create an history table to keep the previous value and to be able to calculate the bonus again on the previous period. So it's also something that can be done. So here's the concept, and now let's see how it will work really in a data model for this case. So on the top, just as a reminder, it's our 2 rule to calculate the bonuses. So in this case, usually what we will have is that we will have an order table, because the first step will be to calculate the total sales per month for each sales representative. So globally, we will have this order table with 1 line per order. And the thing is that step 1, we will need to aggregate the data, so per period, and then also per sales representative to get the total sales. Once it's done, we have to, in the meantime, so to use this parameters table. It means that at the end, so it's on the final step, for each sales rep, we will be able, with a combination of step 1 and step 2, to create the final step to calculate the total bonus. So for each sales representative, and so for each period, we will be able to get the different parameters. So for the rule 2 and 1, to calculate the final bonus. So to calculate the 5% of total sales for each sales rep, and to see if they meet the expectation for the rule 2. So if they get the bonuses or not. So finally, we will get this total bonus. And as you can see, in this with this structure, it's easy in case of evolution of the parameters to still get the total bonus as it's on the parameters table, and you do not have to apply the change in every formula. So that's it for the concrete case. So at the end, what we can say on the parameters table is that in terms of benefits, the thing is that it will be much more easier to use the parameters table to have it on all the variables in one place instead of using it in a multiple area. It means that it can be, as we saw in the previous dashboard, it can be in multiple formula. So here we are sure that data are centralized. So it's in one place, the parameters table. And so when there is some evolution, it's easy to change it in one place instead of all the formula. So in the meantime, it's more effective because for sure it's quicker. And it's more accurate because you reduce the risk of error. So this is it for the parameters table. And on the next subject, we have normalization. So we will go through the same kind of step. Here it will be to see together how can we use crosswalk tables to facilitate the data analysis. So first, what is behind crosswalk tables? So first, you will see that finally we will have multiple name for this kind of tables. I will just talk about crosswalk tables, but we can also name it cross-reference tables or mapping tables. In terms of definition, it's structured data tables that facilitates the translation or the mapping of data between different classifications. So in terms of example, this time, let's take the example of a multinational company where each country has its own product hierarchy to classify all their products. So basically, it's the same product in the different countries, but the ID is not the same. So in terms of use case, what will be the challenge here? It will be that as it's a different ID for the same product, how to create a global analysis. So first step, like this, it will be complicated, and especially with consistent results. The second thing is how to easily switch results from one country to another one. Again, because it's not the same kind of ID, it will be very complicated. So in this case, we will use the crosswalk tables. So let's go on this slide. So here, the goal to help the analysis will be to map the products hierarchy from each country to a common one. Like this, we will harmonize the data, and we will finally be able to analyze, for example, the total sales by category, and also to compare the sales performance across the different countries. In terms of how is structure the crosswalk table, so you can see an example here. So let's assume that, for example, on the country A, you have this kind of IDs on the category product, on the subcategory, and even at product level. We will do the match for each level of the hierarchy between all the different countries. So it will be a table like this, and at the end, you will see the common hierarchy that will be used to make the analysis. This one will be used on the dashboards. So finally, with this kind of table, it will be easy on the dashboard, on all the different analyses, to have global results, okay, at multinational level. It will be easy to switch on the results from one country to another one, because your data will be harmonized. and it will give the opportunity to have a view like at group level. Again, so here it's like the parameters table. It will be centralized. So it means that if the product hierarchy is changing at some point, even if it's at one country level, it's centralized, so it's easy to change. It's more effective, again, because it's in one place only. And so it's more accurate. So at the end, with the crosswalk table, your analysis can be easily performed. So yeah. So this is it for this part. So Shri, I give you the floor.
Yeah, thanks a lot, Audrey. Thanks for walking us through different examples on how to use parameters. And I've seen some questions coming around how to use those parameters, so we'll try to answer them at the end. We have just two more topics to cover, and before we get into the questions. So the first topic we're going to talk about is a little bit about cross-functional data. Before we get into talking about how to set up the data structure in the right way, let's just try to understand what cross-functional data sets are. So typically in an organization, you're working with multiple data sources. You have your CRM, you have your accounting, marketing, payment. This is just a typical data representation of a organization. And probably this is 5% of what the organization is using. There are multiple other applications that are also involved in the whole organization process. So when it comes to so many varied data sources, it becomes challenging to create a single representation or a single summarized report that can give us at a glance what's happening across different functional teams. For instance, in this example that we have taken, imagine you have a CRM system, and a typical contact table on a CRM system contains fields such as the creation date of the contact, the ID of the contact, the first name, last name, along with a lot of other fields. An accounting software would typically have an invoice state with invoice ID, amount, client name, and a few other invoicing detailed information. The marketing might have information such as the date of visit, the source of visit, the number of visitors. And your payment system, which might be external to your accounting, could have your payment date, the invoice that the payment was happening on, the amount that got paid, and what's the status on the payment. So these are few different tables that you might end up dealing with. But imagine if you had to create a desired output that looks like something like this, where you have a daily summary, which represents date in column one, the number of visitors, number of contacts, the invoice amount, and the paid amount. And now you also want a monthly summary. You're working with four separate tables, and out of these four separate tables, you have to represent a singular table on your dashboard or either on your reports. So how would you combine these different sources together? There are two approaches that you end up taking. The first approach that we're going to talk about is a join. That's typically what comes to your mind when you have to combine multiple tables together. I have 5 tables. Let's just join them, try to get everything into one single table and use that. Creating a join, so this is a representation of a join. Creating a join has its own challenge. You have 4 tables which do not contain a single primary key. They do not contain a single date. There is probably missing dates in some cases. Maybe on your CRM data, you have no contact created on Saturday or Sunday, but you have marketing traffic still visiting your website on Saturdays and Sundays. Or you have no payments on your payment table on weekends, and you still continue to have invoices that are sent out on weekends. So you can necessarily, you can join the tables, but creating a join with not a single unique key might have issues. Even if you do an outer join, you're going to have blanks in some of your date columns. You might have no values in your creation date. You might have blanks on your payment dates. So how do we solve this? If this is the desired output that we want, we know that we need to join the tables to get to our desired output of one single table representing all the four key KPIs. How can we resolve that using a join? The way we have suggested in the past is if using join is the way to go based on your data, then have a separate table, maybe a calendar table. A calendar table now ends up providing a single date field. You know that there is always a date on your calendar table for each day in the year. That provides a single source for all your connecting tables. You can join your date from your calendar with your accounting data, date from your calendar with your CRM creation date, and similarly for the other sources. This avoids the issue of missing dates, but it's still not optimized. This setup now is creating unnecessarily number of columns. Instead of having one date column, you have 5 date columns. And from these 5 date columns, I need to somehow get back to this desired output of having only one date column or having only month column. I still have 5 date columns that I need to answer for. Maybe I need to do some post transformation and try to combine them and put them in one column before I go ahead and create a dashboard. So creating a join as well has some limitations. And also it's not the best way in terms of optimizing for performance. It's unnecessarily creating joins between multiple tables, creating multiple columns, and it's very performance intensive. So to avoid such scenario, there's a simple approach that you could end up using. And this is the approach we typically take while working on projects. It's in a database term, it's the union, or on Click Data, we also have something called as fusion that we refer to as union, where you can combine different data sets together, almost like stacking one on top of each other. Imagine you were able to stack all these 4 tables and have one column that gives you the date, one column that gives you the number of contacts, one column that gives you number of invoices. That's what a union would allow you to do. With a union, you can start mapping your columns. You could say that the invoice date on my accounting should go to a column called as date. The CRM date or the creation date from my CRM should also go to a column called as date, and so on and so forth. I can map all my date columns and represent it into one single column. I can map all my metrics and have my invoice amount, my contact, number of contacts, number of visitors back into one column. And I can create a category that allows me to easily identify each set of this data. So setting up a data in this manner will be effective for performance, will allow you to have a single row to represent dates, so you don't have to worry about missing dates or incorrect values. And you'll have a single column giving all your metrics, so you can display it as a pivot table, you can display it as a chart, you can display it however you want. It's a flat data structure that you will end up coming with, which can be used for multiple scenarios. To round up this cross-functional analysis, so the cross-functional analysis challenges, it's derived from multiple sources. Joins of data might pose some challenges on missing entries. And some of the examples that you will come across are the accounting system, if you're working with vendors containing payments, if you have traffic data from marketing, if you have status, leads, or deals data from CRM. So these are some of the cross-functional data examples that you will end up facing. And if you're trying to set up a data model for such examples, do remember creating a union might be the best way to go for this particular setup. It will make it easy for reporting. The next topic we want to talk about is cohort versus non-cohort. How do we analyze group data sets, when we should do it, how we should do it, what kind of data we should structure for such analysis as well. So before we dive into the data structure, let's talk about what a cohort and non-cohort would give. Typically, cohort looks at the data from a group perspective. You either group your data in specific cohorts, in specific groups. There is always a time aspect with the cohort data. It's always looked about at a particular time. If how many users joined this particular week and what happened with those users, or how many users joined in that particular month and what happened with that particular set of users. So it's really a mechanism for us to track the behavior or performance over time for a specific set of users. The best way to think about is how many students joined a particular batch and what happened with that batch of students rather than looking at all the students in a particular university or school. The second use case that most of us do today is a non-cohort way of looking at it. It is something that focuses on overall trends, observations for an organization. We don't end up grouping individuals or data into specific subsets. It doesn't necessarily have a time component. As in my previous example, I just said, if you're looking at a university, I might look at all the students in a particular university rather than looking at a student who has joined a particular batch in a university. So that's a non-cohort way of looking at something where you don't have a time aspect and you're not bound to a specific subset. So typically, while working with cohort examples, there are a few different kinds of representations that you're looking for. One representation that we've come across more often than not is how do we show evolution of a number of users that have come to our platform? Consider a mobile app. A mobile app developer would be interested to see how many users installed our app in a specific month and what happened with that subset of users. Out of the 100 users that installed in Jan 2023, how many did I retain the first week? What was my retention rate second week, third week, and so on? So in this case, we want to analyze the retention information within a cohort fashion. And a similar example where we want to look at that in a non-cohort way, you would try to look at it at an average retention rate. Here we are not looking at how many users joined in Jan and what happened with those, but I just want to see on an overall level, how is my app doing? What is my retention rate typically? What is my average retention rate for week one? What is my average retention rate for week two? Doesn't matter when someone installed the app, doesn't matter when this new user was acquired. It's in general for all the users that I have on my system. A second representation of cohort that we have seen is working with sales team. Let's say you're trying to analyze sales activity for your organization. You typically work with multiple deals. Each deal either gets won, lost, or it goes on hold. So here, what we're trying to do with the cohort representation is we're looking at specific subset of deals. If I have 100 deals, what happened with those 100 deals? So you will see for each row, the total always adds up to the number of deals. I'm always looking at 150 deals in February. Out of those 150, how many were won? How many were lost? Whereas in a non-cohort fashion of looking at the same thing, we are not looking at the deals that were created in a specific month, but I'm just looking how many deals did we win this month? We have 130 deals that were won in the month of Jan 2023. These deals could be created last year, could be created in the same month. So it doesn't matter when this was created. I'm just interested here looking at the number of deals that were lost in a specific month, irrespective of the time when they were created. So hopefully this gives you some idea of what a non-cohort representation answers and what a cohort answers. Let's try to see how you can structure the data to effectively show that representation. The first example that we had, I'll just open that slide again. Here we have the number of users that installed an app in a particular month, and we would like to see retention by week. Your usual transactional data might not have a row for each week. It will typically have, this is the date the user joined, this is the date that they left. So this is how a transactional data might look like, the left top table. Here I can see that a particular user, each row represents a user. A user joined in Jan 2023, and then they left on 14th Jan 2023. Then a second user or third user joined in Feb, left again on 19th of Feb. So what we start doing is we have a batch ID where we can easily see each user and what kind of time period that they started on with. For us to represent the data in this format, we need to be able to create those missing week of data. We need one row for each week. And how do we get there? So the first step we do is we start by joining a table with a calendar table. We try to use a less than operator so that we can start filling missing weeks. For the first entry, I would like to start filling missing weeks so that I have week 1 and week 2. With the transform data, you could see out here, for user 1, I have week 1, week 2. There are 2 rows that got created. For user 2, who joined in Jan and left in week 3, I have 3 rows created after the join. Once I have the data structured in this way, I can easily go ahead and start creating a cohort analysis. Now I have a row that represents the user behavior at a particular given point of time, rather than just a single row that tells me when they started and when they joined. For each week, I know if the user was still active, if the user was not active. And once I have that, it's a simple table that I need to represent, simple table that I need to create to come up with the representation. In our second example of cohort, we try to look at the number of deals that were created in a specific month and what happened with those deals that were created in that month. For such scenario, your CRM data will usually give you multiple deals, multiple columns. You might have a date when the deal was won, the deal was created, when the deal was won, and when the deal was lost. For us to look at one deal and understand what happened with that deal, it's fairly easy. All we need to know is that deal, did the deal go in any of the statuses? If the deal is just 1 right now, the number I have is 1, and I know that the deal just got 1. If the deal was also lost, I create a calculation and I put that this deal was also lost. If the deal is not on either of the first 2 status, I know it's on hold. So here we are using simple calculations to create 3 additional columns, which classifies the deal based on the state and looks at 3 different date columns to come up with that particular classification. Once I have the data structured in this way or transformed in this way, I can easily go ahead and use my deal date as my first column, the deal ID as my second column to get a count of deals. And I already have 3 separate columns created for each of my status. And I can just do a sum of each of those status. And I have a cohort representation of what's happening with my deals in a particular month. So I hope this webinar gave you some ideas on how you can design the data in a bit different way, how you can start using parameters to make your rule writing easy, how you could restructure using crosswalk tables, how you could use fusion as opposed to joins, which is typically what most of us start thinking, let's use a join if you have 5 different tables to connect rather than looking at a union. A union is also a good way of combining different data sets. And how you can effectively structure the data by using calculations to come up with cohort, non-cohort, or other sort of analysis. So we're going to give just a minute for people to write down the questions. We already have a few questions coming in, and we're going to take the last 5 minutes just answering some of the questions that we have so far. Okay, Audrey, I'm going to go ahead and just ask some of the questions which seem to be parameter for the parameterization things. The first question I have is, do you have any recommendation on what's an ideal source table to use for the parameterization? I think you already mentioned local tables, but is that the only source table to use, or do you have any other suggestions on how people can structure that?
Mm, yeah, in fact, you have multiple choice. I mean, so yes, we talk about some Excel files, for example. So I am in Excel or CSV or whatever. The thing is that in this case, it can be a manual update. So if it's not so frequent, you can do it manually, like every 6 months or once a year or whatever. What you could have also, especially if it's more frequent in terms of updates, is that you could use Cloud Sheets or Google Sheets or things like this. So like this, it's better in terms of updates. One of the choices is that the parameters table can be directly into a database. So it means it's really part of your database. And in this case, in terms of update, it will be more on the IT side. So in terms of sources, to define the ideal source for you, it will more depends of your expectation in terms of date frequency, and also who will be in charge of the update of the data in case that there is an evolution of the values.
Awesome. Yeah, I think that makes complete sense. If you're updating it frequently, then try to have it on a source that is accessible easily. And if it's once a year, like revenue targets or sales commission targets for your sales team, you could also have it on a manual table or even have your IT team put it down on a database table. So that's a good suggestion. The other question I have around the same topic is, how do we understand what are the number of variables that need to be defined for the table? Is there a secret formula, or is there something that easily tells you I need this number of variables?
No, I don't think that there is a limit in terms of number of variables you should restrict on your parameters table. But if your business demands multiple values, you should create a parameter table with multiple variables. And however, the end objective of a parameter table is to be able to use them in multiple cases, as we saw during the webinar. I think that about refining the variables or creating the variables, the most important thing is to creative a way where we can limit the numbers or have limited but manageable numbers of variables. At the end, I think that, and in my experience, I would recommend to really structure the parameters table as much as possible and to try to keep it clear and simple, but it doesn't mean that you have to limit the number of variables. You could have a lot of them. If it's still clear and usable, it will be good.
That's a good suggestion. And I think the other thing is, yeah, if you're working with multiple departments, then try to categorize them either based on use cases or departments. Don't have too much, but don't have too little. Have enough so that you can automate the process. I think the goal of creating a parameter table is you don't have to write a manual formula every time a new rule is placed in your business. It has to be defined in such a way that you can just input some variables and it will automatically create that formula for you and take care of doing the calculations so that you can have a dashboard that is live, dynamic, and can also adapt to changing business situation because your rules are going to change. Maybe your strategy is going to change. So try to incorporate enough variables, but don't try to go overboard. So I guess that's a good answer. I have another question. I think this is more around, I want to say it's more around cohort or non-cohort. Actually, it's more around data structure for Fusion. So the question is, we spoke about how you can create Fusion to get a single table out of cross-functional data set. And is there a way of using Fusion for consultants who are working with multiple clients? So yes, there is a Fusion can be of advantage when it comes for a consultant or OEM provider who is dealing with multiple clients. They might not have four separate tables from different departments, but they might have four separate tables from different clients. And if you need to create a dashboard, one approach is you create a dashboard for each of your client. But the second approach is rather than creating a dashboard for each of your client, why don't you create a union of the data sets, create one single dashboard that points to all your clients' data, and then use what Audrey is suggesting in terms of creating a parameter table so that each client can get access only to their respective data. So maybe create a parameterized table, as Audrey has suggested, along with a multi-tenant setup on click data, like using user parameters so that if client one logs in, a dashboard that is built for all the client will only display client one's data. If client two logs in, then it only displays that data. And the best way to accomplish that is by creating a union or a fusion between those data sets. So rather than having four client tables separate, you have one single table. And probably instead of a category column, you have a client name that allows you to identify each client's data or a client ID or something of that sort. Okay. We have a few more questions, but we're also running out of time for today's webinar. So we will get back to the questions through email. If you have any other questions or if you have anything else to comment, don't hesitate to reach us out at sales@clickdata.com, support@clickdata.com. Hope this webinar was helpful and you got some points to take back and implement in your data designing process. Thanks a lot, Audrey, for sharing your insights, your experience while working with clients. That was really helpful. Thank you, everyone.
Thank you.